Welcome to this presentation. We are going to solve another statement problem. A logic circuit have three inputs A, B and C. The output F is high when the majority of inputs are logic 1. So this is the statement and we have to minimize the function. We have to minimize the function F and we have to implement this circuit. So let's start with it. We have to make the truth table first. We have three inputs. So we will have 8 possible combinations. A, B, C are the three inputs and 8 possible combinations are 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and finally 1, 1, 1. So these are the 8 combinations and we have to find out the function f, and we will use this statement to find out the function f. The output f is high. It means the output f is equal to 1 when the majority of inputs are logic 1. We have 3 inputs and if majority of inputs are 1, we have to take the function f as 1. For the first case, we have all the 3 inputs equal to 0, so function f is going to be 0. For the second case, we have 2 inputs as 0 and 1 input as 1. So again function is 0, function equals to 0. For the fourth case, b is 1 and c is 1, so function f is 1. For the fifth case, again function is 0. And for the last 3 cases, the function is 1 because the number of ones are more as compared to the number of zeros in the input bit stream, and we are going to use the truth table to find out the function f. We only have to consider the cases when the function is high. So we have 4 such cases and thus we will have 4 min terms. I hope you remember the min terms, and for the first case we have a as 0, b as 1, c as 1, so a complement b c. For the second case we have a as 1, b as 0, c as 1, so a b complement c. For the third case we have a as 1, b as 1, c as 0, so a, b, c complement, and for the last case all the 3 variables are high, so a, b, c. So we have the function but we want to minimize the function, so we are going to use the Boolean algebra to minimize this function. I will take a, b common from the last 2 terms, so we have a complement b, c, or a, b complement c, or a, b. In bracket we will have c complement or c, and we already know x or x complement is equal to 1, so c complement or c is equal to 1. Function f is a complement bc or a b complement c or a b, because ab and 1 is equal to ab. Now we will take a common from the last 2 terms and we will have b complement c or b in the bracket, and if you remember the distributive law, x complement y or x is equal to x or y. This is very simple. So in this case we will have a and c or b. I will open this bracket by using the distributive law and we will have ab or ac. Now we can take b common from the first 2 terms and we will have a complement and c or a, and again we will use the distributive law, this law, and we will have c or a, b or ac. Finally we will have ab or ac or bc. So this is the answer, the minimized function that we have obtained from this statement, and now we have to implement the circuit. So it's very simple to implement this circuit. We have to use 3 AND gates and one OR gate, and remember this one OR gate is 3 input OR gate. So we will do it quickly. We require 3 AND gates. The first AND gate will have input A, B. The second AND gate will have input A, C. The third gate will have input B, C. We have implemented this A, B by using this AND gate. Let's say A1. We have implemented A and C by using this AND gate A2, and finally B and C by using this AND gate A3. And now the output is AB, AC, BC, and we have to OR them to obtain our function f. So we will OR them by using 3 input OR gate, and the output of this OR gate is function f. So this is the second part of the problem in which we had to implement the circuit. This is all for this presentation. This is how the statement problem will be asked in the exam. If you have any doubt regarding any part of this lecture, you may ask in the comment section.